Assalamu alaikum. I'm Abdullah Nafis. I'm from book 7. So now I'll present the constructive solid geometry and its operation. So here is the agenda of today's presentation. At first the introduction, then the operations, union, intersection, difference, and advantages of CSG, and last the conclusion. So at first the introduction. The definition of CSG, I mean the constructive solid geometry is a method for creating 3D models by combining simple shapes using Boolean operations. So these Boolean operations include the union, intersection, and difference. So, and it allows for the creation of complex shapes from simpler building blocks using the CAG. So we can also, by using the CSG, it is possible to create 3D models that would be difficult or time consuming to create using traditional modeling techniques. And CSG is commonly used in computer aided design, the CAD, and also in video game development and other engineering and architectural applications. The fundamental concepts of CSG is that 3D shapes can be broken down into simple geometric shapes and then combined using the Boolean operations to create more complex shapes here. So next, we have the example of operations. So it is union, intersection, and difference. And here is some example picture of union, intersection, and difference. And some example shapes are spheres, cubes, cylinders. We can combine these shapes. Next, we have union. So what is union? Actually, union, it combines two or more shapes into a single shape. For example, if you have a sphere and a cube and want to combine them using the union operation, the resulting shape will have the shape of both a sphere and also a cube. It will contain all the volume of the sphere and the cube and will be a single unified shape that includes all the parts of both the sphere and the cube. It is represented mathematically as a logical OR operation where the resulting volume is the one that is present in any of the original volumes. And also union operation is also known as the merge or add operation. Next, we have intersection. So intersection creates a new shape that consists the overlapping parts of two or more shapes. For example, if you have a sphere and a cube and want to combine them using the intersection operation, the resulting shape will have the shape of only the parts of the sphere and the cube that overlaps. It will only contain the volume of the parts of the sphere and the cube that overlap and will be a new shape that is formed by the intersection of the original shape. And it is represented mathematically as a logical AND operation where the resulting volume is the one that is present in all of the original volumes. Intersection operations is also known as the common or overlap operation. So next, we have difference. So difference, it subtracts one shape from another. So for example, if you have a sphere and a cube and want to use the difference operation to subtract the sphere from the cube, the resulting shape will have the shape of cube with the sphere removed from it. The resulting shape will only contain the volume of the cube that is not overlapped by the sphere. It is represented mathematically as a logical NOT operation where the resulting volume is one that is present in the first original volume and not in the second one. So difference operation is also known as the subtract operation. Next, we have the advantages. So advantages of constructive solid geometry is easy to create and modify complex shapes. So CSG allows for the creation of complex shapes by combining simple building blocks, which can be easily modified or updated as needed. Next, we have flexibility and control. So Boolean operations such as union, intersection, and difference offer a high degree of flexibility and control over the final shape, allowing for precise adjustments to be made. Next, we have the wide range of applications. So CSG can be used in a variety of fields, including computer-aided design, CD, video game development, and engineering and architectural applications. Next, CSG have a lot of efficiency. So using CSG can be more efficient than traditional modeling techniques as it allows for the creation of complex shapes in less time. Next, we have reusability. So the building blocks used in CSG can be easily reused for other shapes, making it easy to create a library of reusable components. Next, we have simplicity. So the use of Boolean operations makes the process of creating 3D models relatively simple and easy to understand, even for those without a background in computer graphics. Next, we have the integration with other modeling techniques. CAG can be integrated with other modeling techniques such as NURBS or polygonal modeling for more flexibility. And last, we have the compatibility with modern software. So CAG is supported by many modern 3D modeling and animation software, and making it easy to use in. So these are the advantages of CSG. Last, we have the conclusion. So to sum up, we can say that CSG is a powerful technique for creating 3D models by combining simple shapes using Boolean operations such as union, intersection, and difference. It offers a simple and efficient way to create and modify complex shapes and has many practical applications in various fields. So that's all for the presentation of CSG, Constructive Solid Geometry. Thank you very much for listening to our presentation.